Hello, and welcome to distillation in a nutshell. The process of distillation has been around for thousands of years and can be traced back to the ancient Greeks. Since its discovery, the distillation process has been vital knowledge in shaping and changing human societies. But what is it? Simply put, distillation is a process used to separate mixtures. Separation is achieved because of differences in volatility. If a solution comprised of two miscible liquids varying in volatility are heated, the more volatile substance vaporizes first due to its lower boiling point. In this experiment, an ethanol and water solution were separated using two methods, simple and fractional distillation. This was the distillation apparatus used for the experiment. The ethanol water solution was put into the distillation flask here. As the solution heated, the ethanol vaporized much sooner than the water because it is a more volatile substance. The ethanol vapor then entered the condenser, where it was cooled back into the liquid phase and later collected. One complete cycle of evaporation and condensation is the function of simple distillation. A total of 15 milliliters of distillant was collected, and the temperature was recorded for every half milliliter increment. To achieve a richer distillant, the fractional distillation method was used. This method introduced a fractionating column filled with glass beads to the apparatus. The beads in the column increase the surface area for the condensation of water. The more surface area, the greater the separation. As the alcohol evaporated and traveled up the column, so did a small amount of water. As the water traveled up the column, it got further from the heat source, condensed on the beads, and returned to the distillation flask. Each time water vapor climbed, condensed, and returned to the flask was considered one cycle, as in simple distillation. The major difference in fractional distillation is that water vapor is constantly climbing, condensing, and returning to the distillation flask, allowing for multiple cycles and a richer distillant. This graph shows the changes in temperature as the distillant was being collected. The blue line represents the simple distillation, and the green line represents the fractional distillation. After a certain point, the temperatures spike up abruptly. This change indicates that the original mixture contained little or no more ethanol, and the apparatus was vaporizing water. Notice how the simple distillation line starts to climb after 7 mLs collected. Then the system begins to vaporize water. 7 mLs of alcohol collected per 15 mLs of distillant yields an ethanol percentage of 47%. The fractional distillation line doesn't increase till after 11 mLs, which yields a much richer distillant containing 73% ethanol. To this day, distillation remains a viable method for separating mixtures using differences in volatility. Well, I hope you've enjoyed distillation in a nutshell, and keep it in mind next time you fill up your car with gasoline or enjoy a shot of smooth-aged whiskey with a friend. Take care.